Are you preparing for Unix or Linux interviews? Whether you are aiming for a estate, DevOps, production support, SRE, system admin or a developer role, your Unix fundamentals must be solid. In this video, I am breaking down the top 25 real-time Unix interview questions with examples and scenarios directly from real industry experience. So let's begin. Hi everyone, welcome back to the channel. Today we are diving deep into Unix interview preparation. By the end of this video, you will know the exact type of questions companies ask, how to answer them and how to demonstrate real world problem solving skills. So let's jump straight into question 1. What is the difference between Unix and Linux? This is a very basic question, and here mainly hiring managers check if you understand the ecosystem like Red Hat, Ubuntu, AIX, Solaris. First, let's talk about where both of these operating systems came from. Unix was created in the early 1970s at AT&T Bell Labs. It's one of the oldest operating system and formed the foundation for many modern systems. Linux came much more later in 1991 when Linux Torvalds created it as a free open source alternative to Unix. So Unix is the original system while Linux is a modern open source Unix like system. Next thing is ownership. Unix is mostly proprietary. Different companies own different versions like IBM AIX, HP UX and Oracle Solaris. Linux is open source, licensed under the GPL. Anyone can view the code, modify it and create their own distribution. That's why we have many Linux distros like Ubuntu, Red Hat, Debian and Arch. Then you have cost. Unix usually requires a paid license and officially vendor support. Linux is mostly free with optional paid support for enterprise versions. Hardware support. Unix typically runs on a vendor specific high-end hardware. Linux is extremely flexible. It runs on almost anything: laptops, servers, cloud platforms, mobile devices and even IoT. Stability and performance. Both are stable and high performing. Unix is known for long-term reliability in enterprise environments. Linux is also very stable and distributions like Red Hat and SUSE are widely used in production. Security. Both systems are secure, but the difference is in update speed. Unix updates depend on the vendor. Linux benefits from a global open source community, so security patches are released very quickly. User interface and commands. Unix was originally command line based with some GUIs added later. Linux supports both CLI and modern GUIs like GNOME and KDE. Most commands feel similar because Linux is Unix like. Real time world usage. Unix is still used in large enterprises, banks, telecom companies and data centers. Linux is everywhere today in servers, cloud computing, DevOps, containers, Android phones, embedded services and supercomputers. So that's all about the difference between Unix and Linux. If you want to give a clean, strong answer, here is the answer. You can just read it one more time. We'll move to the next question. How do you check running processes in Unix? Interviewer can also ask you same question with a scenario like your service is slow. How do you find CPU heavy processes? First, let's quickly understand what a process is. A process is simply a program that is currently running in the system like a script, a service or an application. To see what is running right now, we can use a command like ps or top command. So ps stands for process status. So running ps command will show you the processes running in your current cell. Okay, so if I'll just show you ps minus ef, so here you can see all the processes running are listed here. So in ps minus ef, minus e means all processes, okay, and minus f means full format with more details like user, PID, parent PID, and the command used to start the process. Okay. If you want to get a real time live view of running processes, then you can use top command, TOP. Okay. This will give you real time live view of all running processes. So, here you can see, right, PID, command, percentage of CPU, time. Okay. So, it updates automatically every few seconds. Okay. So, this is very useful to check things like CPU usage, memory usage, which processes is taking the most resources, load average, okay, running process, sleeping processes. So, remember this line, PS is static but top is live. Okay. So, another very common way to find a specific process is combining PS with grep. Okay. So, you can write PS minus EF, then your pipe command, then grep whatever process you are looking for. Let us say you are looking for SSH. Okay. Okay, we do not need to give this extra space here. Okay. This directly prints the process ID of all SSH related processes. Okay. So, this command will show only the processes related to SSH. You can replace SSH with any process name you want to search. Okay. There is a similar way to search processes using pgrep. Okay. So, you can write, let us say, pgrep then SSH. If I will write pgrep, let us say OBS. So, this gives the process ID, okay, 4280, or pgrep, let us say Chrome. Okay. So, this give me the PID of that particular process. So, pgrep is basically a shortcut to avoid using PS and grep together. Another useful command is PS tree that shows processes in a parent child format. Okay. You can try that as well. Okay. So, from the interview perspective, if you want to answer, here is a detailed answer, you can just read it one more time. Okay. We will go to the next question. How do you kill a process? This is something every QA engineer, system admin, DevOps engineer or support engineer must know. Before we kill a process, we first need to find or identify the process. Okay. So, you can do this using PS minus EF. Just now we saw how to find the process ID using PS minus EF command, or using the top command we can see the live processes. Okay. So, once we get the process ID, then we can kill that process. Okay. So, to kill that process we can use kill, let us say that process ID is 1234. So, we can give kill 1234. Okay. So, here we see multiple processes are running. Okay. So, if we want to run any particular process, these are the process IDs, we need to find these PIDs and then we need to kill this. Okay. So, let us say we want to kill Python process. Okay. So, PS minus EF, let me search for Python. Okay. So, 503 is the process ID for this. Okay. So, if I need to kill this process, so what I need to do? I need to write kill 503. Okay. When we use kill minus 9, okay, so sometime process do not respond to the normal kill. Okay. So, in that point of time we can use a force kill. So, we can write kill minus 9 503. Let us say this kill 503 is not working. So, we need to forcefully kill it. So, we can use kill minus 9. Okay. So, kill sends a gentle termination request, while kill minus 9 forcefully kills the process. Okay. So, if you want to kill something forcefully, you can always use kill minus 9. So, there is another command you can use pkill. Okay. So, you can use, let us say, pkill. Okay. And let us say you want to kill the Chrome command, sorry, Chrome process. So, you can write pkill Chrome. Okay. This will kill all processes with the name Chrome. There is another useful command, you can use kill all. Okay. So, you can use kill all to kill all processes with a given name. Let us say kill all HTTPD. So, this will kill all HTTPD server processes. It is very helpful when multiple instances of the same application are running. Okay. So, I explained you how do you kill a process? Here is a detailed answer for your interview. Just read it one more time. Okay, we will move to the next question. Explain file permissions in UNIX. So, in UNIX, every file and every directory has a set of permissions. These permissions control who can read, who can write, and who can execute that file. So, the purpose is simple: to protect the system and ensure only authorized users can access or modify files. There are three types of permissions. Okay. So, one is read permission. It will allows viewing the file content or listing a directory. Write permission allows modifying the file or adding or deleting a file in a directory. Execute, so allows running a file as a program or entering a directory. Okay. These three permissions are applied to three categories of users. So, what are those categories? One is owner, then another one is group, and last one is others. So, owner is the user who owns the file, group is the user who belongs to the same group as the file, others is everyone else on the system. Okay. So, each file has permissions for owner, group, and others. Okay. So, here if we will run the command ls-l, so here we see we have two files and one directory, but how we will know which one is a file and which one is a directory? So, when you did this ls-l, here you see 10 different characters. Okay. So, let us break it down. So, the first hyphen, right, this is for a file. So, here you see this abc.txt and xyz.txt, it starts with a hyphen, it means these are files, but this books, so this is a folder or directory, that is why it starts with D. Okay. So, the next 9 characters represents permissions in a group. Okay. So, first 3, okay. So, first 3 are owner permissions. Okay. Next 3 are group permissions. Okay. Then last 3 are others permission. Okay. So, here what is the owner permission? You can see RW and then hyphen. So, what is this RW and hyphen? So, it means read, write and no execute. But for this one, what is the permission? For the group level, what is the permission? Only read. Okay. No write, no execute. Same thing for others. But here in this case, right, RWX. So, RWX means read, write and execute. So, the owner has permission for read, write and execute for this books directory. Okay. Similarly, for this one R-X, it means read, no write and execute for group permission. Same thing for others. Okay. Here also you can see read, write and no execute, read, no write, no execute, read, no write, no execute. Okay. So, this is how you can understand the permissions. Okay. What and all permissions we have. Okay. Permissions can also be represented using numbers. So, read will be always like 4, write will be always 2, execute is always 1. Okay. You can add them to get the permission value. So, let us say 4 plus 2 plus 1 equal to 7, right. It means 4 is for read, that is why R. Then W is 2, X is 1, that is why RWX. Okay. Similarly, 6 is 4 plus 2, it means RW and hyphen, read, write and no execute. 5 is 4 plus 1, 4 you know is stands for read, that is why you can say read and 1 is stand for execute. So, no write, read, no write, only execute, that is 5. 4 is only read, no write, no execute. So, a very common example if I want to give you. So, let us say I will put chmod, okay, and 755, okay, and let us say we will give this file name abc. So, what will be the permission we are giving? First we are giving 7. 7 means 4 plus 2 plus 1, read, write and execute. Okay. 5 means what? 5 means read, no write, only execute, because 4 plus 1. Okay. Same thing for this one. So, what will happen here? Let us see, and now again we will do ls-l. See, earlier it was only read and write then hyphen, but now it is read, write and execute, because we gave chmod 7, then 5 means what I told, read, no write, only execute. That is why here we shall read this much, read, no write, only execute. Same thing for this also. If you just want to see 7, 5, 6, right, let me give this, you will see the difference. Now do ls minus l, see, read, write, execute, then read, no write, only execute, then read, write, no execute, because 6 is 4 plus 2, 4 is for read, 2 is for write, okay, and then no execute. So, all this I explained for your understanding, but for your interview purpose you can give this answer. So, read it once, okay. We will move to the next question. What is the difference between symbolic link versus hard link? A symbolic link or soft link, like a shortcut, okay, it points to the file name. If the original file is deleted, the soft link breaks. A hard link is a second name for the same file. Even if the original file is deleted, the hard link still works. Okay. So, this is the major difference. If the original file is deleted, hard link still works, okay, but if the original file is deleted, soft link breaks. Okay. So, example here you can see soft link example ln minus s file 1 dot txt, then link 1. Hard link example is ln file 1 dot txt link 2. Okay. We will move to the next question. How do you search for files in UNIX? So, interviewer can also ask you same question with a scenario like how to find large files which is eating disk space. So, the most powerful and commonly used command to search for files in UNIX is find. For example, if you want to search in the current directory, you can use find dot then minus name file name. Okay. So, let us see with examples. So, first see what and all files we have. So, here we see we have 3 files, one JPG file, 2 TXT files and one directory books. Okay. So, if I need to find, let us say this xyz.txt file. So, I am in the same directory, how I will search for it? So, I can do find dot, then I can put minus name and then that file name. Okay. So, see, I got the particular file. Okay. But let us say I want to find all the files which are .txt files, right, or sometime in the real time maybe you need to find all the files which are like log files, right, .log which ends with .log. How you will find it? So, you can write find dot, because we are in the same directory, name, okay, and here we can give star dot txt, because we want all the txt files, right. See, inside book also we have a txt file, that is why that also getting listed. Okay. So, in this way we can search, let us say in a real time example all the log files we want to find, right. In this way we can easily find it. Okay. If you are not in the current directory, you can give the exact path where you want to search it. Okay. So, if you want to find files larger than let us say 100 megabyte, right. So, we can write find minus size, okay, and then we can say plus 100 m, sorry, I need to put find, right, find, let us say put dot where we want to search. Okay. So, here we do not have any file. Okay. So, let us say I need to put find dot size minus 1k. Okay. So, basically here I want to search for files less than 1 KB. Okay. That is why find dot minus size, okay, then minus 1k. So, this will search files less than 1 KB. Okay. So, if you want to search files more than 1 KB or more than 2 KB, let us say, okay, only this file is more than 1 KB, okay, because all other files are less than 1 KB, right, that is why it got listed here. So, this is how also you can find the larger files, the smaller files. Okay. So, for the interview purpose you can give this answer. Okay. We will move to the next question. What is the difference between grep, egrep and fgrep? The word grep stands for global regular expression print. Okay, so it is used to search a text or pattern inside files. Okay, so for example, here I have a file abc.txt, right? So let's see what is there inside abc.txt. Okay, so let's say we have here hello. Okay, so let's say we want to search grape. Okay, and then we will search this hello grape. Where we will search? We will search inside this abc.txt file. Okay, see, we got it, right? So similarly, if you let's say search hello something which is not there, right? See, it is not there. Okay, so grep supports basic regular expressions like dot for any character, star for 0 or more, okay, dollar for end of line. So grep is ideal for simple pattern matching. Okay, then what about this egrep and all? So egrep stands for extended grep and it supports extended regular expressions, also called ERE. Okay, so this included more advanced pattern like plus means one or more, question mark is 0 or 1, then or operation, grouping parenthesis. Okay, so let's say we are inside a log file or something. So let's say we can search something egrep, then let's say error or warning. Okay, then let's say that file name abc.log file. Okay, I don't have that file here, but yeah, you can search something like this. Okay, so this search for both error and warning inside a log file. Okay, and then fgrep stands for fixed grep. Okay, this version doesn't treat the pattern as a regular expression, instead it matches the exact string. Okay, so special characters like dot, star, question mark lose their meaning and are treated as normal text. Okay, so if you will give let's say fgrep a star b file.txt, it means a star b is nothing but a complete string. Okay, this search for the exact characters. Okay, not regex pattern and all. Okay, so for the interview purpose you can give this answer. Okay, you can read it one more time. Okay, we will move to the next question. What is a shell script and why it is used? Interviewer can also ask you same question with a scenario like how you will automate log cleanup, backup, monitoring works. So a shell script is a simply text file that contains a series of shell commands. Instead of typing commands one by one manually, you can put them in a file and run it as a single pattern. So the concept is simple. A shell script automates commands. Okay, for example, we will create one script, let's say vi script.sh. Okay, here what we will do, we will just write echo and hello. Okay, and then maybe we can just do a ls minus l. Okay, so our script contains this much only. Let's save it, and now we need to run this script. Okay, so how we will run it? Sh then script.sh. See, it printed this hello, okay, whatever echo we have added, and then it just did a ls command. So listed, okay, that ls minus l whatever we have written inside this script.sh ls minus l, that printed all these things. Okay, so shell scripts are used for many reasons like automation. Shell script automate repetitive tasks like backups, file processing, deployments and cleanup jobs. Simplification, instead of running 10 commands manually, you put them in a script and run in one command. Scheduling, shell scripts are used with cron jobs to schedule tasks automatically like daily, weekly or monthly basis. System administration, admins use shell scripts to manage users, monitor logs, manage services and handle system tasks. Application deployment, DevOps team rely heavily on shell scripts for builds, deployments, environment setups and CI/CD pipelines. Easy to write and modify. Shell scripts are simple text files, no need for heavy programming knowledge. In one line, we can say shell scripts save time, reduce manual errors and make tasks consistent and repeatable. Okay. So in your interview, you can tell this exact answer. Okay. You can read it one more time. We will move to the next question. How do you check disk usage? Interviewer can also ask you same question with a scenario like your server is out of space, how you will find which folder is used. So the first and most commonly used command to check disk usage is df. df stands for disk file system. So it gives the disk usage of all mounted file systems, but the output of df can be hard to read because it shows data in blocks. So the most commonly used format is df minus h. Okay, so minus h means human readable format, which shows size in MB, GB and all. Okay, so let's see how df minus h works. So here if we just put df minus h, so here you can see the total disk size, use space, available space, okay, mounted path. So all these things we can see here. We can also check disk usage of a specific directory. So here we have this directory, right, books. So let's say if we want to see for this books directory, we can just write df minus h then books. Okay, so here we have only one file, right? So we can see that. So there is one more command known as du. Du stands for disk usage, okay, and it shows how much space a file or directory is using. Okay, so let's say we just want to do du, okay, and then let's say the same folder books. To make it more readable, we can use du minus sh then books. Okay, so it means the entire directory uses 4 KB data. Okay, so if your interviewer asks a question like if you need to find which folder is consuming the more space, then you can always use this du minus sh. Okay, then maybe you can put a star. Okay, so here you can see books folder is taking 4.0 K and then these files is taking 276 K. So maybe this is the one which is taking the highest space. Okay, so to answer your question, here is the detailed answer. Okay, you can read it one more time. Okay, we'll move to the next question. Explain cron tab and how scheduling works. First, let's understand what cron is. Cron is a time-based job scheduler in Unix and Linux. It allows you to run scripts and commands automatically at scheduled times like every minute, every hour, daily, weekly or monthly. So instead of running a task manually, cron executes it for you. Now the word cron tab comes from the cron table. A cron tab is simply a file that contains a list of scheduled jobs. Each user on the system can have their own cron tab file. So you can open or edit your cron tab using cron tab minus e. So if we go to our terminal, here we can see cron tab minus e. Here we can have our own entry. There is nothing for now, that's why we don't see anything here. Okay, so to view all your cron tab jobs, what we can do, we can just write cron tab minus l. Okay, so we don't have anything cron tab here, that's why we don't see anything. Okay, so let's say we want to run this script.sh at 3 AM every day, then we can set it as 0 3 star 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 in our cron tab. Okay, so how this format works, so here you can see, right, minute. So minute is like 0 to 59th minute. So hour is 0 to 23. Okay, so you can put 0 1 2 3 till 23. Next thing is day of month, so 1 to 31st, whatever you can put it here. Then month 1 to 12, whatever you can put it. Then day of week 0 to 7. Okay, so 0 and 7 are Sunday, 1 is Monday. Okay, so like that you can continue. So for your interview you can explain this. Okay, you can read it one more time. Okay, we'll move to the next question. How do you monitor memory usage? So interviewer can also ask you same question with a scenario like how you will detect memory leak in Java app. Memory monitoring is extremely important for troubleshooting system performance, and interviewers expect you to know the key commands. So the most commonly used command to check memory usage is free. It shows details about total memory, used memory, free memory and buffer or cache. Okay, so the most popular version of free is free minus h. So if we will go to our terminal and we will run free minus h. Okay, so here we can see memory means actual RAM usage, then swap memory usage. Okay, so available is like memory available for all applications. Okay, so free minus h is the quickest way to get a summary of overall memory. Okay. So then there is one more command which is top. So top gives you real time view of memory usage, then CPU usage, running processes and all. Okay. Here you can see total load average. This is great for monitoring memory continuously. Okay. Again there is another command that is known as vmstat, which stands for virtual memory statistics. It shows memory usage, swap activity, system processes, IO statistics and all. Okay. So to answer your question, here is the detailed answer. You can read it one more time. Okay. You can give exact this answer. We will move to the next question. What is inode in Unix? This is one of the most fundamental concepts in Unix and Linux file systems, and interviewer asks it to test your understanding of how files are stored internally. An inode stands for index node. It is a data structure in the Unix file system that stores metadata about a file. In other words, information about the file, not the file content. So every file and directory in Unix has an inode. An inode stores several important details about a file, including file size, file owner, file permission, file type, number of links, timestamps like created, modified or accessed, then the location of the file's data blocks on disk. So you can think of an inode as a file's identity card. Okay. An inode does not store the file name. The file name is stored in the directory structure, which maps file names to inode numbers. This is why the same inode can have multiple file names using hard links. So every inode has a unique number. You can see the inode of a file using ls minus I, then file name. So here you can see the inode number. Okay. So directories also have their own inode numbers. So the clean and simple answer for you is here. Okay. You can give this as your answer. Okay. You can read it one more time. We will move to the next question. How to check open network ports? This is a must know topic for system admins, DevOps engineers and anyone working with servers or troubleshooting network issues. So when we say check open ports, we mean checking which ports on your system are currently being used by applications and listening for connections. So this helps you troubleshoot network issues, identify running services, check if a port is available, debug firewall or connectivity problems. One of the classic command to check the open port is netstat. So to list all listening ports, we can use netstat, okay, minus TULN. Okay. In TULN, T stands for TCP ports, U stands for UDP ports, then L stands for listening ports only, N is show numeric port values. Okay. So if you also want to see which process is running a port, then you can use netstat minus TULNP. Okay. So minus P flag shows the process ID and application name. So on the modern systems, the recommended command is again SS, which stands for socket statistics. Okay. So you can use something like SS minus TULN. Okay. So to list again ports along with the process using them, then you can use SS minus TULNP. Okay. So SS is faster and more accurate, especially on high traffic servers. So to answer your questions, here is the detailed answer. Okay. You can read it one more time. Okay. We will move to the next question. What is the difference between absolute path and relative path? So a path is simply the location of a file or directory in the file system. There are two ways to specify a path, using an absolute path or using a relative path. An absolute path is a complete path that starts from the root directory, which is represented by a forward slash. So it gives the full location of a file or directory from the very beginning of the file system hierarchy. So an example is /home/user docs then file.txt. So here you can see the complete path, okay, starting from the root directory. That is why it is an absolute path. Okay. Similarly, let us say /etc/password. Okay. again this is an absolute path starting from the root. Okay, so all absolute paths always start with a forward slash. Okay, then a relative path does not start from the root directory, it starts from your current working directory. Okay, so the meaning of relative path depends on where you currently are. Okay, so let's say we are in some folder, okay, and then we are trying to find that file. So let's say doc/file.txt. Here we are not starting with the root, okay, we are not starting with the forward slash. Okay, so this is your relative path. Okay, so these paths do not start with a forward slash and they are interrupted relative to your current directory. Okay, so to give a clear answer in the interview, you can say this. Okay, you can read it one more time. Okay, we will move to the next question. How do you extract, compress and archive files? Okay, so to compress a file, we can use gzip. Okay, let's say we have a file abc.txt. Okay, we want to compress it, so we can use gzip. Okay, then the file name. Now you do a ls, so you see abc.txt.gz. Okay, this formed. Okay, so this replaces the original file with the compressed file. Okay, so originally it was abc.txt. When we use gzip, then it became abc.txt.gz. Okay, so to extract or uncompress this gz file, what we can use? We can use gonzip. Okay, gonzip, and then maybe we can use this abc.txt.gz. Okay, so what it become? Now again we can see it as abc.txt. Okay, so let me do it again. Let me just do gzip again. Okay, so here you see abc.txt.gz. Okay, we can also use gzip. Okay, minus d, then this particular abc.txt.gz. Okay, this will also extract it. Okay, now you see this also got extracted. Okay, so to create a tar file, what we can do? We can use tar minus cvf. Okay, let's say we want to create tar file of this books folder, right? So let me give it as books.tar. Okay, and then I'll give this books folder. Okay, so ls, now you see books.tar created. Okay, again to extract it, what we can do? Tar minus xbf, then we can say books.tar. Okay, so you see again it got extracted. Okay, so to answer your question, here is the detailed answer. You can read it one more time. Okay, we will move to the next question. What is a shell? What are the different types of shells? A shell is a command line interpreter in Unix and Linux. It takes commands types by the user and passes them to the operating system to execute. In simple words, a shell is a program that allows you to interact with the operating system. It is the layer between the user and the kernel. A shell performs several important functions like it interprets commands, executes programs and scripts, handles input and output, supports variables and functions, provides scripting capabilities. That's why we also use shell scripts for automation. So popular shells are sh, bash, ksh, zsh. Okay, so to check your shell, what you can do? You can just write echo $shell. Here you can see zsh used. Okay, we'll move to the next question. How do you check environment variables? Environment variables are key value pairs that store system level or user level settings. So they help programs understand where files, executables and configuration exist. There are different ways to check environment variables. So one way is print env. So if you just put print env, you can see the environment variables. This command prints all environment variables currently set in your session. So to check a specific variable, what we can use? We can put print env, okay, and then we can give that particular name home. this prints the value of only that specific variable. Okay, we can also use env command. This displays all the environment variables similar to print env. So, to see one variable, we can also use echo and then $home. Okay. So, we can also talk about how to set variables. So, for temporary setup, we can use export variable equal to value. For permanent setup, we can add it to bash.rc or profile or bash profile. Okay. So, to answer this question, you can give this answer. Okay. You can read it one more time. We will move to the next question. How do you redirect outputs to files? Okay. So, redirection is a core concept in UNIX because it allows you to control where your command output goes, whether to the screen or to a file or even to another command. So, the interviewer wants to check if you know about this or not. So, what is the command we will use to redirect to a output file? Okay. So, let me just clear it. So, here let us say we have these files, and now let me just do this ls output to a different file. Okay. So, ls, you just need to use this particular command, then output dot txt. Okay. Now, let us see this output dot txt files, you just see this got created, and if we just do cat of this output dot txt file, you see all this. So, here when we use this particular symbol, right, and then we did ls, then this, then output dot txt, it means the output of ls got added to this particular file. Okay. You can give any name here, that should be fine. So, to answer this question in your interview, you can talk about this. Okay. We will move to the next question. How do you compare files? File comparison helps you to find changes between versions, identify mismatched configuration file, debug issues, compare logs, verify deployments. Okay. So, UNIX provides multiple tools for this. So, the most commonly used command to compare files in UNIX is diff. Okay. So, if we will go to our terminal, okay, and here let us say we have this multiple files, right, abc.txt, and then we have this xyz.txt. Okay. Let us say we want to do a diff of abc.txt and then xyz.txt. Okay. You see, these are the difference. This shows the line by line difference between the two files. Okay. So, for a cleaner and more readable format, what we can do? We can just use diff minus u. Okay. So, this is the format most of the developers use for code review and all. Okay. We can also do one thing. So, let us say we have these two files, right. So, let me just copy this to abcd.txt. Okay. So, basically these two files are same, right, abc.txt and abcd.txt. Okay. So, what we will do? We will just do diff of abc.txt and abcd.txt. See, because these two files are same, right, that is why we are not seeing any difference. Okay. We can also use, instead of this diff, you can also use cmp. Okay. This will compare files byte by byte. So, this is useful when you want to check if two files are exactly identical. Okay. If the files are identical, it prints nothing. If they differ, then it shows the first point of difference. Okay. So, in this case these are same, right, but if we will put xyz.txt, it can show that in the line 1 only there is a difference. Okay. So, to give a clean and confident answer, you can say this. Okay. You can read it one more time. We will move to the next question. What is piping and how does it work? So, piping is one of the most powerful feature in UNIX and interviewers love asking about it. In UNIX, piping is a technique used to pass the output of one command directly as the input to the another command. We use pipe symbol for this. Okay. So, instead of storing output in a file or printing it on the screen, we can send it instantly to another command for further processing. So you can think of a pipe like a water pipe. Water flows from one end to another. So in Unix, data flows from one command to another. Okay. For example, if you want to list all files and then search for a specific file, then what you can do? So here we have all these files, right? So let me just do like this, ls minus l, then pipe command. So this is the pipe command. Okay. Then grep, let's say I will just search for abc. Okay. See, we are getting two output because I am searching for this abc, right? That's why I am getting abc.txt and abcd.txt. So here ls minus l, this one, it lists the files, and then this grep, this particular abc, it means it is filtering only the files whose name is abc, right? That's why we are getting these two output. Okay. Similarly, if you want to count how many processes are running, what we can do? We can use ps minus ef. Okay. Then we can just do wc minus l, ps minus ef, then pipe, then wc minus l. So here ps minus ef will show you all the processes, wc minus l, it will count the number of lines. So together they show how many total process exist. Okay, here you can see 556. So to answer this question in an interview, you can say this. Okay, we will move to the next question. How do you check the last 100 lines of a log file? So logs are crucial for debugging, monitoring and troubleshooting. So interviewers expect you to know this perfectly. So to see last 100 lines, we can use tel minus 100, then that particular log file name. Let's say log file name is file.log. Instead of that, if you have any other name, you can give that name as well. So if you want to see all the logs, live logs, then you can do tel minus f, then file.log. Okay, the log file name. This is useful while debugging applications. We use the tel command to view the last lines of a log file. Okay, by default tel shows the last 10 lines, but we can customize it using tel minus n. For real time log monitoring, we use tel minus f, which keeps displaying new log entries as they are added. Okay, we will move to the next question. How do you find the number of lines in a file? Okay, so to count the number of lines, we just saw in our previous question, right? wc minus l, then give that particular file name. Okay, so this is useful when checking log size or file structure. Okay, so this is the exact command. You can use wc minus l, then file name. We will move to the next question. Explain the difference between ampersand and non-hub. These two are often used together, but they are not the same. Interviewers love this question because it checks whether you understand background processes and session handling. So the ampersand symbol is used to run a process in the background. When you add ampersand at the end of a command, so the shell does three things. It starts the command, it runs the command in the background, it immediately returns the terminal prompt, so you can continue working. But remember, if you close the terminal, a background job started with ampersand will get terminated because it is still attached to your terminal session. For example, if I will put sleep, okay, and 60 and then this ampersand. Okay, so this runs sleep in the background, but if you close the terminal, it will stop. Okay, if you use no hub, it allows your process to keep running even after the terminal is closed. No hub stands for no hang up. Okay, so we can simply use like this no hub, okay, and then your particular command no hub sleep, this one. Most of the time we use no hub and ampersand together like this, no hub sleep and then 60 and then ampersand. Why we use like this? Because no hub makes sure the process does not stop after logout and ampersand sends it to the background. So together you get background process immune to logout, no hang up on terminal close. So in your interview you can just talk about this exact answer. Okay, we will move to the next question. How do you check system uptime? So to know how long the system has been running, we can use uptime. Okay, so it shows load average also, or we can use WHO minus B. It will check last system reboot. Okay, we will move to the next question. Explain exit codes in Unix. In Unix and Linux, every command returns an exit code after it finishes running. This exit code is also known as return code, exit status, status code. It is a number that tells whether the command succeeded or failed. There are many exit codes, but two are the most important one. One is 0, which is equal to success, that means the command ran successfully without any error. Non-zero means failure. Any number other than 0 indicates that some error or problem occurred. You can see these are the different exit codes, like 0 is success, 1 is general error, 2 is misuse of shell built in or incorrect usage, 126 is command found but not executable, 127 is command not found, 130 is script terminated by Ctrl+C, 137 is killed by system. Okay, so these codes help developers and admins understand what went wrong. Okay, so we can check the exit code by doing echo. Okay, then you can just put a dollar and question mark. So here you can see 0. 0 means successful. Okay, our previous command was executed successfully. Let's say again I will put ls, it was a successful, right? So I will do echo and then this, then we are getting 0 because our previous command which was ls, this was successful. Let's say I will just do ls, then let's say I will put something which is not there, right, .txt, because this dgds.txt file is not there. Okay, so what we got? No such file or directory. Now you just do again echo, then this. Here we will not get 0, we got 1. 1 means general error, because previously whatever the command we used, that was not executed successfully, or we didn't find something here, right? This file was not there. Okay, that's why we got a generic error. Okay, so to answer in your interview, you can just tell this. Okay, you can read it one more time. So that's all for this video. Thanks for watching. These 25 Unix questions are some of the most asked in interviews for DevOps, SDETs, SRE, support, developers and system admin roles. If you have any question in your mind, please drop a comment below. Don't forget to like, subscribe and share this video with anyone preparing for interviews. Thank you so much.